Okay, let's have a look at the difference between molecular and empirical formulas. First of all, both of these formulas are telling me something about the number of atoms of elements present in a compound. More specifically, the molecular formula tells me the actual number of atoms of each element that are present. Empirical formula, on the other hand, is the simplest whole number ratio of atoms of each element present in that compound. So there's a subtle difference between them, and let's have a look at some examples. First of all, let's take the molecular formula C2H6. That's telling me that in my molecule I have 2 carbons and 6 hydrogens. Now, in order to find the empirical formula, or the simplest whole number ratio of carbons to hydrogens, what I need to do is find the highest common factor in the number of each element. In this case, both numbers would be divisible by 2. And I'm going to simplify that ratio by taking the 2 carbons and dividing that number by 2, which would be 1, and taking the number of hydrogens, 6, dividing that by 2, that would be 3. So you can see in my empirical formula I have the same ratio of carbons to hydrogens, but I've just simplified those whole numbers. Let's take a second example, C6H6, or benzene, that you'll see at some point in the course. Again, I'm looking for the highest common factor of 6 and 6, and well, I could divide both those numbers by 6 to give me 1 carbon and 1 hydrogen in my empirical formula. Let's take water. Now in this case, I've effectively got 2 hydrogens and 1 oxygen in my molecule, and because there's only 1 oxygen already, I actually can't divide those numbers any further without breaking away from integers. So in this case, the empirical formula is actually going to be exactly the same as the molecular formula because I can't simplify that ratio. Finally, let's take a slightly complicated looking one, and this is a totally made up molecule, so don't expect to see it anywhere. C12H8N4O2. So again, to convert that to an empirical formula, I'm looking for the highest common factor in those little subscript numbers, and I think the biggest number that I can divide them all by is going to be 2, which means my empirical formula will be C6H4N2O. Remember, you don't need to put a little 1, we can just leave that off. So that's the first part of the video. The second bit, and this appears in the occasional exam question, they will give you information about the empirical formula of a substance, and they will tell you the molar mass of that substance. And the molar mass is referring to the actual molecule, so it would be the molecular formula, not the empirical formula. So we would be asked in these kind of questions to calculate the molecular formula. So how do we do that? Well, we're going to do a little hypothetical here. I'm going to calculate the molar mass of my empirical formula. So let's do the first row. In my empirical formula, I've got 1 carbon, which has a molar mass of 12 grams per mole, and I've got 2 hydrogens. Each of those would be 1 gram per mole, so in total would be 2. If I add those up, I think my maths is correct, the molar mass, or hypothetical molar mass of my empirical formula is 14 grams per mole. And I know from the data I'm given in my question that the actual molar mass of the molecule, the whole molecule, is 28 grams per mole. So all I need to do now is work out how many times the molar mass of my empirical formula goes into the molar mass of the molecule itself. And in this case, I would need to take 2 chunks of my empirical formula before I get to the molar mass. So what does that mean? Well, it means my actual molecular formula is going to be double the empirical formula. So in this case, C2H4. Let's try perhaps the second row. Let's get rid of this stuff. Okay, same process. We're first of all going to work out a hypothetical molar mass of the empirical formula. This time I've got 1 carbon, that's 12 grams per mole. I've got 2 hydrogens again, that would be a total of 2 grams per mole. because there's 2 of them, and I've got 1 oxygen, which is going to be something like 16 grams per mole. So if I add those up, I get a total molar mass for my empirical formula chunk of 30 grams per mole. And I need to get to a total of 180 grams per mole, according to the data in my question. And with a bit of simple maths, I know that 30 multiplied by 6 is going to get me there. So my molecular formula is actually going to contain 6 units of my empirical formula. So I'm simply going to multiply the number of each atom by 6. That's going to give me C6H12O6. And if you do a bit of biology at some point, you might recognise that as the molecular formula of glucose. And that's pretty much it for this video. Hopefully it was of some help.